In problem 4b on practice exam 3, we are asked to predict the product and draw the mechanism for the elimination reaction. This is an example of E2 elimination, and here's why. We have a secondary alkyl tosylate in alcoholic solvent without addition of water to prevent formation of carbocation. So the less polar the solvent system, the lower the dielectric constant, and therefore the potential carbocation will be less stabilized by the solvent cage. So any addition of water would increase the dielectric constant of the solvent system. We have fairly concentrated strong base, 1 molar sodium ethoxide, and therefore these conditions will favor E2 elimination. I like to number the carbon atoms starting with the carbon bearing the leaving group, and then I proceeded counterclockwise toward the nearest substituent, and I did the same on the chair. Now let's go ahead and fill in the missing substituents. Carbon number 1, I have tosylate group pointing up. On my chair conformation, carbon number 1 is pointing up, axial bond will be up, equatorial will be down in the same direction as bonds 2, 3, and 5, 6. And then I will put tosylate up since it's attached via wedged bond, and hydrogen will be equatorial and down. Carbon number 2 is pointing down, so axial bond will be down behind the front bonds. Equatorial will be up in the direction of bonds 1, 6, and 3, 4. Going back to the cyclohexane, I have ethyl group pointing down. So here's my ethyl group. Hydrogen is up and equatorial. Carbon number 3 is pointing up on the chair conformation. Axial bond will be up, equatorial down in the direction of bonds 4, 5, and 1, 2. Methyl group is up and hydrogen therefore is down. Next, I will make sure that I had drawn all of the alpha hydrogen atoms. Alpha hydrogens are those on the carbon atoms next door to the alkyl halide or alkyl tosylate carbon. Therefore, my 2 alpha carbons are carbon number 2 and carbon number 6. Carbon number 6 is pointing down. Its axial bond will be down, equatorial up in the direction of bonds 4, 5, and 1, 2. This is a secondary carbon atom with 2 hydrogens. Next, I will find if there is a alpha hydrogen that is axial and also antiperiplanar to the tosylate group. Tosylate group is axial. On carbon number 2, I do not have an axial hydrogen atom, but I have one on carbon number 6. Therefore, I am unable to follow the Zaitsev rule in this example because the more highly substituted hydrogen atom at the alpha position is equatorial. And in the E2 elimination, we cannot deprotonate carbon whose hydrogen is in equatorial position. So therefore, we have to deprotonate the less highly substituted alpha position, carbon atom number 6. My mechanism involves base, methoxide, abstracting the hydrogen from the backside, bond between carbon number 6 and hydrogen will be broken. Its 2 electrons will collapse toward the incipient pi bond that will form between carbons 1 and 6, and tosylate group will be expelled. Again, for the E2 mechanism, we have 3 arrows. Abstraction of the hydrogen ion, formation of the pi bond, and dissociation of the leaving group. It is clear from this mechanism that the double bond will form between carbons 1 and 6, giving us less highly substituted alkene product. Double bond between carbons 1 and 6, and let's go ahead and fill in the missing substituents. Carbon number 1 has hydrogen left since tosylate was dissociated. Carbon number 2 has ethyl group pointing down. Carbon number 3 has methyl group pointing up. Since the alkene is disubstituted because I have carbons 5 and 2 attached directly to the double bond, this is a non-Zaitsev product. Zaitsev product would have double bond between carbons 1 and 2. So I will designate this product as a non-Zaitsev disubstituted alkene. Examples 4a and 4b together illustrate how during the E2 elimination reaction you form the Zaitsev product if the antiperiplanar arrangement of the leaving group and the alpha hydrogen is possible, and you form the non-Zaitsev product when there is no alpha hydrogen on a more highly substituted alpha carbon that occupies an axial position and antiperiplanar to the leaving group. The rate of the E2 elimination reaction depends on the concentration of the alkyl halide or alkyl tosylate in this case and the base. For example, if we have the concentration of the alkyl halide but double the concentration of the base, the reaction rate would not be affected.